Okay, moving on, we'll look at FM synthesis. So frequency modulation synthesis is a little bit different concept from probably what we're used to thinking about when we're working with synthesizers, but it's one of the most basic premises that we use for dealing with sound that changes in some way. And if we think about all complex sound is changing in some way almost all the time. So the gist of frequency modulation synthesis is that you are modulating the frequency. And modulation is really just a fancy word for to change. But how you are changing the frequency is tightly controlled. In this case, we have a primary oscillator, and the primary oscillator is the oscillator that's creating the sound that we're listening to. And oscillators draw waves. In this case, oscillator tilde makes a sine wave. Now, frequency modulation means we're going to change that frequency, and in this case, we change it around a fixed center frequency. We can think of frequency modulation synthesis as really just fancy vibrato. And when you talk about vibrato, that's something a singer or any instrumentalist learns to control. You have very slow, wide vibrato. Whoa. That's kind of an extreme vibrato. Or you could have very tight, quick vibrato. Whoa. Something like that. And so in both those cases, there's a fixed pitch, wah, and then there's a variation around that fixed pitch, wah. So you can hear that movement up and down around the primary center frequency. So here I've got plus tilde 440. 440 is our center frequency in the FM synthesis chain. Then I have the frequency of the vibrato around that frequency. So I could set this to 1. And then I've got the distance of that vibrato. So in this case, I'll just start it at 10. And turn up the volume. So we can hear that moving up and down every second. Now if I were to make this 100, our vibrato moves up 100 hertz above and below our center frequency. So when it was set to 10, the result of this system was an oscillating pitch from 430 to 450 over and over again. If I change it to 100, it's from 340 to 540 over and over again. Let's hear that. So I can change both of these values in order to alter the system in some way. I'll start graphing this repeatedly as well. So even though my volume is turned down, I'm graphing before I get to that mute amplitude change. So you can see the wavelength is getting shorter and longer every second. If I change this to 0.5, you can see it happens every 2 seconds. If I change this to 0.25, it happens every 4 seconds. So if I were to change this by 200, now it's getting wider and more narrow as that oscillation takes place. And the longer the wavelength, the lower the pitch. The shorter the wavelength, the higher the pitch. Okay, so let's take a listen as we change the frequency of vibrato over time. So there's kind of this moment where we hear the oscillation going up and down, and then all of a sudden we can't tell that it's moving up and down anymore. It just becomes this more complex sound. And usually that takes place, between 20 and 30 hertz. Let's take a listen again. So in this case, it's even lower, I think, that it takes place. But you basically don't hear this glissando between pitches anymore. It just kind of becomes this chord that you're listening to. So if I were using line tilde to control this change in the amplitude of modulation, let's keep this at 4 for a second. And I'll set this down to 10. Now I could go from 0 to 1000, or sorry, 0 down to 0 over 1000 milliseconds. Now it's at 0. Now I'll go up to 3000 over 10,000 milliseconds. So you can hear that change over time is quite interesting. What if this were a little bit higher? Let's set it to 30 and do the same thing. Oop, need a little volume. Let's start that over. So you can hear there's a lot of complex sounds that can be created just by changing this value and this value. And then when you're using line tilde, you can change both of these values over time, which creates this changing complex timbre. And in essence, that's what your homework is about this week.